Welcome everyone to AI Tech Talk channel. This is the place where we explore the latest in tech, digging into the modern tools and methods shaping our digital world.
Hi, everyone. I'm Talia. Really looking forward to unpacking today's topic with you.
And I'm Aaron, your host for this deep dive. Today we're focusing on something really crucial for anyone in or looking at technical QA roles, automation testing. Have you come across the term software development engineer in testing, or SDET? You hear it a lot in the QA world.
Oh, absolutely. SDET. It's a big one. Really highlights that developer focus within quality assurance, doesn't it?
Exactly. And, well, if you're aiming for a role like that, or maybe you're just curious how software quality is really ensured, automation testing is, well, it's fundamental. So today, we're going to unpack its technical structure, maybe look at some examples to make it a bit more real.
Sounds good. Where should we start? The architecture.
Yeah, let's start with the big picture, the test automation architecture. The source material breaks it down nicely into inputs, execution, and outputs.
Right. A logical flow. So the inputs,
Hmm.
that's your starting point. You've got the test plan, basically, what you're trying to test.
Okay, the overall strategy.
Yeah. Then the test cases, the specific steps, the checks.
Hmm.
And of course, the test data, the actual information your tests will use. Those are your ingredients, kind of.
Got it. Plan, steps, data that kicks things off.
Yeah.
So what happens in the execution phase? What's core there?
Right, execution. This is where the magic happens, or the automation, anyway. You have the test script, that's your code, the instructions. Then, really key, the test object. That's what you're testing. Could be the whole system under test, like a website, or maybe a specific device under test, like a phone.
Okay, the target.
Exactly. And bridging the gap is the driver. Think of the driver as the translator. It lets your script talk to the test object using specific rules or APIs.
So the driver is the key that unlocks that communication. Script talks to driver, driver talks to the thing being tested. Makes sense.
Precisely.
And then finally, the outputs. What's involved there?
Outputs are, well, how you know if it worked. The main thing is the test report. It tells you what ran, what passed, what failed. Super important. You might also have notifications alerts for the team, maybe for critical failures, you know?
Right, instant feedback.
Yeah, and it's worth remembering this whole cycle often lives inside continuous integration and continuous testing, CICT.
So these tests run automatically, frequently as part of development.
Exactly. Find bugs early, keep the process smooth. It really impacts the speed and ultimately the quality of the software you ship.
That really highlights building quality and not just testing it at the end.
Yeah.
Okay, so let's maybe zoom in a bit, look at a specific test automation process example. The source uses WebDriver.
It does, yeah. WebDriver is, well, it's everywhere in web automation. Think of it like this. You have your client, that's your test script, and it needs to talk to a server to control a browser or a mobile device.
Okay.
So for mobile testing specifically, this often involves something like the Selenium server acting as a hub, and then specific device drivers that know how to handle, say, Android or iOS.
Right. So if we're testing an actual mobile app, not just a website on a phone, how does that communication flow look?
Typically, it starts by figuring out which device you want, so grabbing its unique serial number.
Okay, identify the target device.
Yep. Then, using that number, the system fires up the connection to the app through the right driver. It's not really launching a browser in this case, but initiating contact with the app itself.
Gotcha.
And then finally, your test script executes its steps. Tap this button, enter text here, check that message through that driver connection.
Okay, that paints a much clearer picture of the mobile interaction. Now, the source also details the test execution flow for mobile. Seems like the next logical step. What are the key stages there?
Yeah, the flow. It starts, as you'd expect, by reading the test plan and the test data we talked about.
All right, the inputs.
Then, that crucial mobile step, get the serial number for the specific device being tested. With that serial, it initializes the mobile driver. That's the piece of software that lets our script command that specific phone or tablet.
Okay, driver's ready.
Then the script runs, does all its actions, all its checks, and finally, once it's done, the driver connection is closed. And behind the scenes, you might have tools like adb.exe, that's the Android debug bridge, helping manage the connection.
Wow, okay, so there are quite a few layers involved, from the high-level plan down to device tools like adb. The source also flags the importance of the test plan and test data files, often XML, like xxx.xml. Let's look at that testNG example they give. testNG is pretty common in the Java world, right?
Oh yeah, very popular. testNG gives you a really structured way to set up your tests using XML. So in that example, you see a suite tag. That's like the main container. This one's called smoke test. And notice it says parallel methods and thread count 5. That means it can run up to 5 test methods at the same time. Big time saver for large test suites.
Parallel execution. Definitely see the benefit there, speed things up. What else is in that XML?
You see parameter tags. These let you pass in values. Like here they have platform set to Android, log type, app name, activity, even login details like id and pwd, which, is okay for an example, but probably not best practice for real secrets.
Right, yeah, good point. You'd want a more secure way to handle passwords in a real project. What about the listeners tag?
Listeners are cool. They let you hook into the test run, like do something special when a test starts or fails or finishes. This report log listener probably adds extra detail to the test reports, makes them more useful.
I must have been recording, okay.
Then inside the test tag, you list the actual test classes. Here it's stlogin and register, so those Java classes contain the tests for login and registration.
So that XML file is really the command center, organizing everything. Let's shift to the actual test scripts now. The source mentions annotations in Java, like with testNG. What do those do?
Annotations, yeah. They're like little labels you put on your code. At before sweep, for instance, that tells testNG, run this method once before anything else in the whole suite starts.
Yeah.
And you have others like at before class, at before test, at before method. They run setup code at different points. Before a class, before a test script in the XML, before every single test method lets you set things up just right.
Makes sense. Set up at different levels.
Yeah.
And a test itself is that marks the actual test.
Exactly. At test says, this method is a test case, run it. And just like setup, there's teardown. At after method, at after test, at after class, at after suite, they run after the corresponding tests, letting you clean up, reset things,
Right. Set up before, clean up after. Creates a nice life cycle for the tests. The source shows a snippet from testbase.java. What's a testbase class usually for?
Testbase. Very common pattern. It's basically a parent class for your test classes. You put all the common setup and teardown logic there, like starting the driver, closing the driver. It avoids repeating the same code in every single test class. Keeps things DRY. Don't repeat yourself. Much cleaner.
Okay, promotes reuse. What's happening in that snippet? I see desired capabilities.
Yeah, desired capabilities. That's how you tell the Appium server what kind of test session you want. See, it's setting the device's unique ID from that serial number, the app package, which identifies the Android app, and the app activity, the specific screen to launch.
And then it creates an Android driver connecting to localhost. What's Appium's role here?
Right, Appium. It's the bridge, really. It's an open source server that takes commands from your script via the Android driver in this case and translates them into actions on the actual Android device. So that http://localhost.4723 WD hub is the address of the running Appium server.
Okay, Appium translates the script's commands for the device.
Yep. And that driver.context native app line tells Appium, hey, we're interacting with the app's native UI elements now, not a web view or something else. Yep. And finally, the add after sweep method in testbase shows closing the driver. Super important to release the device and resources cleanly.
So testbase handles the plumbing, letting the individual test classes focus on, well, the actual testing. Let's look at that stxx.java example. What does a test method look like?
Right. This one's called test both empty input. And it follows a really good pattern, the 3A principle. Arrange, act, assert. Makes tests easy to understand.
Arrange, act, assert. Okay, classic testing pattern. How does it apply here?
So, arrange. You set up the conditions. Here, it defines the expected error message string. Please key in your ID.
Got it. The expected result.
Then act. You perform the action you want to test. In this case, it simulates clicking the login button, bitclean login. Probably found using XPath or some other locator.
Okay, trigger the behavior.
Finally, assert. You check if the outcome matches what you expected. It gets the actual error message from the screen after the click. And then it uses assert equals to compare the actual message to the expected one. If they match, the test passes. If not, it fails. That's how you verify the app did what it was supposed to.
That's a really clear example. Arrange the expectation, act by clicking, assert the result. Makes total sense how that validates the software. Now, it's important, like the source says, we've focused heavily on SDT's automation here. But QA is broader than that, isn't it?
Oh, absolutely. SDTs are crucial, especially with their coding skills for automation. But you also have roles like software testing engineers, STEs. They might do a mix of automation and manual testing, test design. Then there are traditional QA analysts, often strong in exploratory testing, understanding requirements, defining test scenarios from a user perspective.
Right. Different focus areas.
And you even have auditors who look more at the quality process, compliance, making sure standards are met. Each role contributes differently to overall quality.
We can definitely explore those other roles sometime. Sounds like a good topic. So wrapping up, it's clear automation testing is, well, it's a critical skill in software development today. And it's definitely more than just coding button clicks. It involves understanding architecture, designing smart tests, writing solid scripts, and really digging into the results.
Yeah, this deep dive into automation, especially thinking about the SDET role, hopefully gives you a good feel for the methods and tech used to, make sure software actually works well.
Definitely. So thinking about all this, what really stands out to you about this structured approach? And maybe for our listeners too, what other testing areas are you curious about?
For me, it's the systematic nature. The planning, the structure from test space to the 3A pattern. It brings engineering discipline to testing. That's for other areas,
Yeah.
maybe performance testing. Or security testing automation. Those are big ones too.
Yeah, suggestions. Well, thank you so much for sharing your insights today on AI Tech Talk channel. And thank you all for tuning in. We hope this look at automation testing was useful.
My pleasure. Hope it was helpful.
Join us next time as we dive into another area of tech. Until then, take care, and we'll catch you in our next discussion.